Good afternoon to all. Today we have to discuss about polymerization. Polymerization, that means monomers combines to form polymer with or without elimination of any small molecules. That is the polymerization. So monomer, that means smallest particles, that means micromolecules combines to form a big molecule. The big molecule name is otherwise known as polymers. So polymer, that means these are the macromolecules which is formed by the repeated linking of large number of small molecules. Small molecules are otherwise known as monomers. So during this polymerization, the number of monomers present in a polymer, that is known as degree of polymerization. So degree of polymerization is low, that means the polymers are known as oligopolymers. Degree of polymerization is high, that means the polymers are known as high polymers. So polymerizations are classified into three types. One is addition polymerization, second one is condensation polymerization, and then third one is copolymerization. So addition polymerization, that means the process of formation of polymers from monomer. Monomers combines to form polymer without elimination of any small molecules. That is known as addition polymerization. So it is a polymerization reaction, but there is no elimination of any small molecules from monomer. For example, ethylene, its molecular formula is CH2 double bond CH2. So n number of ethylene undergoes polymerization reaction that forms polyethylene. That means CH2 bond CH2 up to n times. So it's a best example for addition polymerization reaction. And then next one is a polyacrylonitrile, is formed from acrylonitrile. And also polystyrene is formed from styrene. These are the examples for addition polymerization reaction. And second type is condensation polymerization. So condensation polymerization is also one of the polymerization reaction, but with the elimination of small molecules. So it is a process in which large number of monomers combines to forms polymer with elimination of small molecules like water or HCl or any one of the small molecules. For example, hexamethylene diamine, its molecular formulas CH26 NH2 also NH2, hexamethylene diamine, and also adipic acid COH and CH2 one COH, that is the molecular formula of adipic acid. So the reaction between hexamethylene diamine and adipic acid, that forms nylon 6,6, elimination of water. So it is the best example for condensation polymerization. Then third type is copolymerization. Copolymerization, that means monomers combines to form polymer, but high molecular weight of polymers are produced from copolymerization reaction. For example, reaction between butadiene and styrene, that forms SBR, that means butadiene styrene butadiene rubber. Then polymers are classified into two types. One is natural polymers, second one is synthetic polymers. So natural polymers, that means these are obtained from nature. In synthetic polymers, that means these are prepared in a laboratory. The polymers are known as synthetic polymers or man-made polymers or artificial polymers. So examples for natural polymers are starch, cellulose, proteins, nucleic acids, and natural rubber. These are prepared from plants or animals, that is from nature. Synthetic polymers, that means these are prepared from laboratory. For example, polyvinyl chloride, polyethylene, nylon, Teflon, bakelite, etc. These are the examples for synthetic polymers. The types of synthetic polymers. First one is organic polymer. Second one is elemento-organic or heteroorganic polymers. Third one is inorganic polymer. So organic polymer, that means it contains carbon and hydrogen groups. So elemento-organic polymers, that means carbon and hydrogen groups and also some element groups. Then inorganic polymers, that means these are the polymers but except carbon and hydrogen. These are the inorganic polymers. Then epoxy resin. So epoxy resin, that means it is prepared from bisphenol and epichlorohydrin. During condensation polymerization, epoxy resin and bisphenol combines to form epoxy resin. The property of epoxy resin is resistance to water, acids, alkalis and various solvents and other chemicals. Uses for epoxy resin is surface coatings, adhesives, glass fiber, refined plastics, and second one is Teflon. Teflon, that means polytetrafluoroethylene. Teflon is obtained by polymerization of water emulsion tetrafluoroethylene under pressure of and the presence of benzoyl peroxide. Tetrafluoroethylene molecular formula is CF2 double bond CF2. This undergoes polymerization that forms CF2 bond CF2 up to n times. Teflon, that means it is mainly used for the manufacture of non-stick cookwares. Properties look like a metal but not a metal. It withstands heat and also does not conduct electric current. That is the properties of Teflon. And then polyvinyl chloride, PVC. Vinyl chloride undergoes polymerization reaction and forms polyvinyl chloride. Firstly, vinyl chloride is prepared from acetylene. Acetylene molecular formula is CH, triple bond CH. It can be reacted with HCl up to 60 to 80 degrees Celsius. That forms vinyl chloride, CH2 double bond CH, Cl. Then vinyl chloride undergoes polymerization reaction that forms polyvinyl chloride. The next one is bakelite. Bakelite, that means it is prepared from condensation polymerization. So it is named as thermosetting plastics. So plastics prepared from condensation polymerization are named as thermosetting resins or thermosetting plastics. And also plastics prepared from addition polymerizations are known as thermoplastics. So bakelite is one of the example for thermosetting plastics. So it can be prepared from phenol and formaldehyde in the presence of H plus OH minus, that forms bakelite. And bakelite is used for the finishing and also telephone ports, finishing of electric plates, switchboards, etc. Then next one is polymethyl methacrylate, PMMA. It is prepared from methyl methacrylate. So methyl methacrylate undergoes polymerization reaction that forms polymethyl methacrylate. So polymethyl methacrylate is used for the finishing of mobile phones, laptops, etc. Then SBR, styrene butadiene rubber. So styrene molecular formula is CH2 double bond CH bond C6H5. Then butadiene molecular formula is CH2 double bond CH, one CH double bond CH2. So butadiene and styrene undergoes polymerization reaction that forms styrene butadiene rubber SBR, or otherwise named as polybutadiene co-styrene. So properties of styrene butadiene rubbers are it is a strong and tough polymer. Also, the rubber can be vulcanized similar to natural rubber using either sulfur or sulfur monochloride. Then it is a good electrical insulator. Then it possesses excellent abrasion resistance. Then it resistant to chemical but swell in oils not attacked by even traces of ozone present in the atmosphere. And then it possesses high load bearing capacity and resistance. Then uses of SBR as production of floor files, tank linings in chemical industries, also making wires and cables and insulators. These are the uses of SBR. Then compounding of plastics, that means finishing of plastics. Here there are three processes: blow molding, injection molding and extrusion molding. Blow molding, that means process of heating and cooling of plastics polymer materials. So extrusion, that means elimination of undesired particles. You have to apply a shave. After shaving, undesired particles are eliminated. So injection molding, that means applying a shave for heated polymers or heated plastics. These are the compounding of plastics. So thank you.